I am Dr. Manisha Gupta and I am Assistant Professor in Noida Institute of Technology in MBA department in Greater Noida, and I welcome you in our business research method class. And in today's session we are going to discuss about the hypothesis testing, and we are going to discuss these following topics: the type 1 and type 2 error, two-tail and one-tail test, and the hypothesis testing. And in the hypothesis testing we are going to start discuss a few tests, and in this session we are going to discuss about the t-test. So I start with the type 1 and type 2 error. So what is basically the type 1 and type 2 error? In the context of the testing the hypothesis, there are basically the two types of the error which we can make. First is, we may reject the null hypothesis when the null hypothesis is true, and we may accept the null hypothesis when the null hypothesis is not true. Then this former is known as our type 1 error and the later one is known as our type 2 error. In other words, the type 1 error means that the rejection of the hypothesis which has been accepted, means you have rejected the correct hypothesis, and the type 2 error means you have accepted the hypothesis which should be rejected, means you have accepted the wrong hypothesis. In the type 1 error, what is happening, that we reject the hypothesis which is used to be correct or which we have to accept it. And what is happening in the type 2 error? In the type 2 error, we are accepting the hypothesis which should be rejected, means which is a false hypothesis. And in the type 1 error is basically denoted as a alpha error, and the type 2 known as your beta error. In the type 1 and the type 2 error, the probability of the type 1 error is usually determined in advance, and it is understood with the level of the significance. The level of the significance which shows that how much error we can accept it, means what is the probability of choosing the wrong hypothesis. And if the type 1 error is fixed at a 5%, means you have a fixed level of the significance at the high 5%, it means that there is a chance of 5 chances in 100 that we will reject the null hypothesis when the null hypothesis is correct. So the level of the significance shows that the choosing, there is a 5% chance of the choosing the null hypothesis, rejecting the null hypothesis out of the 100 chance where it is used to be that our null hypothesis is true. And we can control the type 1 error just by fixing it at a lower level, means we eliminate this type 1 error if we maintain our level of the significance at a very low level. And for instance, if you fix it at a 1%, it will say that the maximum probability of committing the type 1 error is just, there is a probability of only 0.01, or you can say it is just 1% of making error, type 1 error. And it can be represented as, the graph shows that suppose null hypothesis is true, but if we accept the null hypothesis, means you are accepting the null hypothesis, then this statement is true. But if you rejected the null hypothesis when the null hypothesis is true, then it is called as our type 1 error, which is represented as a alpha. Now suppose if your null hypothesis is false, but you accepted the null hypothesis, then it become your type 2 error, which is represented as a beta. But if you reject null hypothesis, then it will be your correct decision, and which is represented as in this formula, means alpha is equal to 1 minus beta, or here is also the beta is equal to 1 minus alpha. So this is the just the tabular representation of the our type 1 and type 2 error. In the type 1 and type 2 error, when the testing the hypothesis, the researcher make the correct decision, but it is also at the risk of the committing type 1 or type 2 error. And between the two, researcher always seek to minimize the risk of our type 1 error, and the researcher always seek to minimize the risk of the committing type 1 error. And we can also say that the significant level presented in the risk of the committing type 1 error, means we always talk about the level of the significance for type 1 error. And in practice, the significant level usually vary between the field study. When we conduct the field study, then our level of the significance will vary from, and most of the time we use most common significant level is 1%, 5% and 10%, in which the most time the 5% criteria is used in study. And these significance levels means that you accepting the risk of 1%, 5% of the 10% that you will commit the type 1 error. Now, this is that was all about your type 1, type 2 error. Now, we start the two-tailed or one-tailed test. So, this is also related to the acceptance or the rejection of the hypothesis, and what criteria we set most of the time, what is our significance level. So, in the type 2 or the two-tailed test and in the one-tailed test, what is just showing that it is the context of the hypothesis testing, and these two terms are quite important and must be clearly understood. The two-tailed test reject the null hypothesis if the sample mean is significantly higher or lower than your hypothesized mean. The two-tailed test reject the null hypothesis if the sample means the whatever the mean we get from our sample is significantly higher or lower than the hypothesized value of the mean of the population, such as a test is approximate when the null hypothesis is the some specific value and the alternate hypothesis is the value not equal to the specified value of the null hypothesis. It is happen when, and which is a symbolically we can say the two-tailed test is approximately where this is our null hypothesis, this is a mean of the population, and this is if suppose if the population mean is equal to your sample mean, and HA is basically when your population mean is not equal to your hypothesis mean. So, this statement is basically showing that your population mean is equal to hypothesis mean, and this statement is showing that the alternate hypothesis is accepted when your population mean is not equal to your sample mean, which shows that it may be chances that your sample mean will be greater than or less than our population mean. And what is happening in the one-tailed test? The one-tailed test would used when we are to test and say that whether the population mean is either lower than or the higher than the some hypothesized value. We talk about if it is lower than higher than some hypothesized value, and we should see more briefly here that what is the test of the hypothesis. In this, the hypothesis testing, you are asked to decide and if it is claimed to true or not. For example, if someone saying that the Floridians have the 50% increased chance of the melanoma, means this is kind of the disease which has happened to the in the Florida region, and it is up to you to decide that if this claim hold merit or not, means if this statement is true or not. And for the first step, we look on the Z score, and On the other hand, you need to know that one tail or the two tails, whatever the test we are going to use. So this first part is representing your two tail test. And what is happening basically in the two tail test, there is a, you have make the level of the significance at the 5%, and in the level of the when we put the level of the significance at the 5%, and this is your normal distribution curve which is showing the data. So here you divide the 5% into two part, which is 2.5% and 2.5%, means your null hypothesis acceptance and the rejection region of the two tailed test. The rejection region or the significance level is at 2.5, means at the one tail, means when the value is very less, and if it is less than 2.5, and then the rejection region of the significant level at this point, means two extreme point, either the starting and at the ending point. If they fall nearby your 2.5%, and it is your two tail test, and this region is shown as a total acceptance region on the confidence level, and which is, you can say that, because 1 minus alpha is your beta value, I hope you remember, and this is your acceptance of the null hypothesis. Then if you talk about the one tail test, then you have seen here it is, if you are taking the 5% significance level, it is split into two, and both at the end in 2.5, but in the two tail test the whole 5% will divided at one point, either in the starting point or it will be in a end part, and this is shows the rejection region and the significance level alpha is at your either probability of the 0.05 or the 5%, or you can say there is a 5% chances of your rejection, and this total region of the confidence region is shown as a accepted region. And basically if it is on this side, it is called as the left tailed test, and if this 5% will be on right side, then it is called as a right tailed test. Now what are the steps of the hypothesis testing? So there are the following step of the hypothesis testing, which start with the first step. We make the statement null hypothesis, which is represented as a H1, and also prepare the alternate hypothesis. Now how we test the hypothesis? There is a proper step. In the first step, first of all you prepare the hypothesis, and you have make the both null and the alternate hypothesis. We know that the null hypothesis is a hypothesis which we want to disprove, and the alternative hypothesis is a hypothesis which we trying to prove that this statement is true. So in the first step we prepare our hypothesis statement, null hypothesis and the alternative hypothesis, and in the second step we decide the level of the significance. Then level of the significance is decided, which means how much type, what will be your significant, how much chances or what percent of the chances you are willing to take risk, that is our level of the significance. And in this, under the two sample test H1 and H2, and they are formulated differently, means if you are using the two samples, then you formulate the statement or hypothesis statement differently. And after deciding your level of the significance, we move to identify the test statistics, means what test or the what stats which we want to use to prove our hypothesis. At present time, the most of the time the people try to take t test, z test, regression analysis, correlation analysis to prove our hypothesis. So what is the best test according to our study will be suitable to prove or disprove our hypothesis? And when you decide, suppose you have taken the regression analysis to prove your hypothesis, or you are using the chi-square test to prove your hypothesis. So, you have identified the stats. Then next is formulate the decision rules. Then you have to formulate the decision rule, means how much error you are willing to allow, and then you make decision. And what do you make the decision? After doing this, you test your by after collecting the data, and you apply this test statistics, and at the end, which will show that your result is either you are going to accept or reject null hypothesis. Either if you accept null hypothesis, means you are rejecting the alternative hypothesis, and whatever the result will show. Suppose if with the level of the significance, or there is too much error, or the probability of the chance is the significance of the level of the significance, and the result is very high, it means our hypothesis will be disproved. We will reject the alternative hypothesis and we will accept a null hypothesis. So, after evaluating the data, you take the decision, either you do not reject the null hypothesis, or you reject the null hypothesis. So, this is your steps in hypothesis testing. Next is test of the hypothesis. And basically in the testing of the hypothesis, two types of the test we classify or we use. First is our parametric test or the standard test of the hypothesis. Second is our non-parametric test or the distribution free test of the hypothesis. The parametric test usually assume that the certain properties of the parent population from which we draw the sample. The parametric test is what happen? We usually assume that the certain properties of the parent population from which we draw the sample, and assumptions like observation come from the normal population and the sample size is large, and assumption about the population parameter, like you make the assumption and the parameter, like you may assume that what should be the mean, variables, etc., and must hold goods before the parametric test can be used. So, this was your parametric test. Now, what was your non-parametric test? When the situation, when the researcher cannot or the does not want to make such assumption, means in the parametric test you draw the conclusion or you make the certain assumption by taking the sample from the population and you make the certain assumptions in the parametric test. But when you do not want to make assumption, and in this situation we use the statistical method of the testing, which is called as non-parametric test, because such a test does not depend upon any assumption about the parameters of the parent population. Means in the parametric test we basically make certain parameter, and in a non-parametric test we did not make the parameter which is be drawn from the parent population. So, in the parametric test you make certain parameter of the parent population, and besides this, most of the non-parametric tests assume only nominal and ordinal data, where the parametric test required to measure the equivalent to at least and the interval scale, and such as the result of the non-parametric test need more observation than your parametric test. Here we see the what type of the test is our parametric test and what type of the test is non-parametric test. And parametric test is used when the information about the population is completely known by the means of their parameters, and the what type of the stats we use? We use t test, z test, f test, ANOVA and the Pearson correlation. And what is non-parametric test? If there is no knowledge about the population or the parameters, but still it is required to test the hypothesis of the population, then it is called as non-parametric test. And the example of this type of the test is your chi-square test, Moody's median test, and the Kushel-Wallis test, and the Pearson rank correlation. So these were your parametric and non-parametric tests, and we are going to discuss a few tests from this, and in this session we are going to discuss about the t-test. But first of all, we see the what is the difference between the parametric and the non-parametric test. So first difference is this: the information about the population is completely known as your parametric test, but the information about the population is not available in your non-parametric test. Next is the specific assumptions are made regarding the population. In parametric test, we make certain assumptions, but in non-parametric test, we did not make any assumption regarding our parent population of the study. Now, in the parametric test, the null hypothesis is made on the parameter of the population distribution. Then, null hypothesis, we made the parameter of the population distribution, and in the non-parametric test, the null hypothesis is free from any parameter. Now, in the parametric test, the statistics is based on the distribution, means it is based on our normal distribution, but in the non-parametric test, it is arbitrary, means they are not based on the distribution curve. Now, in the parametric test are applicable only for variables, and the non-parametric test will be available for the variable and also the attributes of our sample. Then the parametric test is the powerful if it exists. It is a very powerful tool if it is exists, means if we have the complete knowledge of the parent population or the population of the study, but it is in the non-parametric test, it is not powerful like a parametric test. And here the non-parametric test exists for the nominal scale data, means there is a no parametric test is available if we are using the nominal scale data, but in the non-parametric test do exist for your nominal and ordinal type of data. So, in the non-parametric test you can also evaluate your nominal and ordinal data, but in the parametric test we did not able to evaluate our nominal data. Now, we come to t-test. So, basically what is the t-test? The t-test tells you how the significance difference between the group are. It is basically comparing the mean of the two different groups, and in other word, let us know the how you know if those difference could have happened by chance or it is, and how it is happened. A t-test is a type of the intervariant statistic used to determine if there is a significance difference between the mean of the two group or not. Suppose if you try to find out what is a significant difference between two groups, means take an example, if you want to know the satisfaction level of the male and the female. So, there is a two group, male and the female, and you can to know about the level of the significance or find out there is a significant difference between the two groups or not, we can use t-test. And the t-test is one of the many tests used for the propose or to proving of the hypothesis. Now, in the t-test, there is a few points there. We have to know about the few terms. This is a t-score. So, t-score is basically is the ratio between the difference between the two groups and the within the groups, and the larger the t-score, more the difference is there. So, t-score is basically trying to tell about the ratio between the two groups, and if the t-score is high, it means that the variation or the difference between the two groups is very much. Now, the t-value and the p-value. So, basically how big is enough, and every t-value has some p-value. P-value is basically your probability value, and the t-value is showing about the ratio or the difference between the two values or the two groups, and the p-value is basically probability that result from your sample data by chance, and the p-values are from 0 to 100%, and they usually written in decimal. For example, the p-value 5% will be written as 0.05, which shows the probability, and if there is a low p value is good. If your p value is good, means there is a chance of the error or the indication that your data did not occur by chance. If your p value is low, then it shows that your data is more authentic and it is not just randomly happen. For example, if the p value which we have taken as 0.5 means, then there is only 1% of the probability that the result from the experiment happened by chance. Now, there is a three main type of the t-test. First is your independent sample t-test. Independent sample t-test is used to compare the mean of two groups. If you want to compare the mean of two groups, then we are going to use independent sample t-test. Next is paired sample t-test. So, paired sample t-test is basically to compare the mean from same group but at a different interval of the time. Suppose you want to analyze the result of the certain student of the particular batch. So, you evaluate this year data, then you evaluate the data of next year and you are measuring their performance. So, in that situation you are using the paired sample t-test. Then one sample t-test, the mean of the single group against the known mean. Here is some example is given which shows the calculation about your t-test. Suppose there is a two groups, group 1 and group 2. Here is a score is given. So, how we calculate basically? So, first of all, suppose this is a x and this is y. So, first of all, what we have to do? We have to suppose, and there is a name of the subject, there is a number of the one group and the other group. So, first of all, what we do? We minus x minus y, whatever the value will get this, then this value should be x minus y square. So, 17, 3 minus 20 you will get minus 17, then we minus square this minus 17 you will get 289 and at the end you will sum up. So, this total value you will get is minus 73 and then you evaluate this value which is 1121 and then we put the formula. So, t value is equal to summation of d divided by n, means n is your number of the observation. So, n value is your 11. Then again in this summation of d square minus d is basically your difference. This is a d value. Then d square, then the summation of the d square divided by n, and at the end in below n is your total number of the observation minus 1 into n. So, we put all the data. D is your minus summation of d is equal to minus 73 is divided by 11, means number of the observation, how many observation is there? 11, and again we divided summation of d square means this value, summation of d square, we evaluate, add all these value, we will get this, then minus, we will put all these data and at the end we will get our t value. This is all for the day. See you in next session.